Hello, and welcome to today's webinar, The Mass Market EV, Just How Close Are We? My name is Chris Robinson, and I'm a senior analyst leading Lux's coverage of mobility innovations that transform the way we move people and things. Before we jump into today's webinar, I do have a quick housekeeping note. We are going to take some questions at the end of today's webinar, so feel free to use the question box on your screen. Now, just a brief introduction to Lux for those of you that may not be familiar. Our goal as an organization is to help our clients innovate smarter and grow faster by arming our clients with the knowledge and tools to help them accomplish that and pick the right technologies to invest in the future. And we do this in a few different ways. So Lux members get access to our platform where we have a database of tens of thousands of pieces of research content, taking a deep dive into startup company profiles or the technologies that they're developing. We also have the ability to work with analysts and content experts like myself. If you have questions on a technology, want to understand a little bit more about how it'll impact your business or a specific company, we can have those conversations. And then lastly, if you have a specific project in mind, we do have a consulting organization that does work on bespoke projects for you. And our expertise spans a fairly wide range of industries, including digital transformation, advanced materials, agri-food and energy, as well as the mobility space. Today's webinar includes research from our Future of Mobility program, which focuses on 4 key themes of research. The first of which is improving urban mobility. As cities grow increasingly congested as populations grow, cities can adopt technology that can help manage congestion, emissions, and ensure equitable access to transportation in the cities for citizens. We also have a heavy focus on autonomous vehicles, as autonomous vehicles are one of the, in my opinion, most disruptive forces in the automotive industry, fundamentally changing use cases of vehicles with ripple effects throughout the supply chain. We also take a close look at shared mobility. Shared mobility includes things like ride-hailing, car sharing, dockless bikes and scooters that are very popular in their usage, but most shared mobility services are not yet profitable. So our research focuses on solutions that can help improve profitability, including hardware, software, and new business models. And lastly, for the focus of today's webinar, is the decarbonization of transit. Transportation accounts for a significant amount of global emissions, and not just in the passenger vehicle space, but also in marine and aviation. There's a push to reduce carbon emissions from the space, including electrification, but also things like hydrogen and fuel cells or sustainable fuel development. And that brings us to today's webinar. And I think it's a really exciting time to actually talk about electric vehicles. From a consumer perspective, a lot of us have the ability to walk into a dealership today and see some kind of plug-in vehicle. Automakers are investing tens, if not hundreds of billions of dollars into developing, designing, building and selling, ultimately, electric vehicles. And a future in which your typical consumer walks into a dealership and is actually realistically considering an electric vehicle isn't that far away. And those are the types of vehicles that I want to talk about today, mass market electric vehicles. So a quick agenda before we get started. I want to start by talking about how we're going to define the mass market EV and understanding just how close we are today. Then I want to focus on the technologies that we believe are going to be crucial in building a future mass market electric vehicle. And finally, end with a discussion on what various industries can do to capitalize on this change. So starting with defining the mass market electric vehicle, I think it's a very valid question to ask. Are we yet in an era of mass market electric vehicles? Certainly that's a question I get, not just from clients, but also friends, colleagues, and family as well when they ask about electric vehicles. And it's an understandable question. We're seeing growth in the number of electric vehicles that are available, and also more types of vehicles that are available. Importantly, seeing not just small, efficient hatchbacks and large, expensive sedans, but a variety of options in different price points and new segments like SUVs. And consumers are reacting as we're seeing a growth in electric vehicle sales. And every year for the last decade, we've seen a new record set in terms of plug-in vehicles sold per year. Now, the future certainly looks bright, and I don't think anyone doubts that. But what about the mass market? So it depends how you define a mass market product. We look at this as something that's intended to be bought by as many people as possible, not just consumers in a certain income bracket or with a specific or special need for a zero-emission vehicle. And Lux has identified 4 aspects that we think are crucial to the mass market EV. The first of which is price. Vehicles need to be affordable compared to similar internal combustion engine-based powertrains for most consumers to consider them. They also need to have adequate performance. Now, here I'm not just talking about things like acceleration and handling. Certainly, electric vehicles perform very well on those metrics. But here I'm thinking more about, does this vehicle, is it able to handle all of the trips and types of use cases I need for a vehicle? So, for those long-range trips, does it have the charging speed? Does it have the range I'll need to get from point A to point B? Now, those are the 2 most common kind of consumer-facing aspects of the mass market EV. But there's also 2 other really important factors that impact automakers. One is scalability. So here, I mean, if we were to rapidly scale up to tens of millions of electric vehicles sold in the next year or 2, does the supply chain exist to make these components? And does the infrastructure exist to actually support charging them? And lastly, but certainly not least, is profitability. Can automakers make money while making electric vehicles? A crucial piece of this puzzle. So to answer that question, are we in the mass market? It's useful to look at the Tesla Model 3, which I think few would disagree with me when I say it is the closest to the mass market electric vehicle that we've seen yet from an automaker. And so thinking about the Model 3 along these 4 quadrants, for the price, they did target a $35,000 selling price. But in reality, once you consider the types of options and packages consumers normally go for with things like autopilot and long range, it's actually closer to a $50,000 vehicle, certainly higher than most consumers would be able to consider. Now, on the performance aspects, I think this vehicle is actually really good. Yes, it takes longer to refuel and has less range than a combustion vehicle, but for the V3 superchargers can provide 5 minutes, 75 miles of range in about 5 minutes, and can go from a full charge from 5 to 90% state of charge in just under 40 minutes. And with 300 miles of range, it's challenging to see how this vehicle would severely impact your ability to travel long distances. Now on the scalability front, this is a little bit more challenging. Its batteries still use nickel, lithium, and cobalt, and with restrictions in the availability and mining capacity of those materials, it would be impossible to scale up to tens of millions of vehicles in the near-term future. And the same can be said about charging infrastructure to support them. We have enough today, and it's growing in deployments. But the scale we need to produce in order for this to be a mass-produced product where most consumers are considering it, we're just not quite there yet today. And lastly, on profitability. Tesla has turned a couple of profitable quarters, but they have not yet turned an annual profit. And looking at some of their peers like GM, with the popular Chevy Bolts, they actually still lose money in each one. So I would argue that electric vehicles are still not profitable, although they're certainly on a path toward profitability. So with these aspects in mind, we can see that the Model 3 is really achieving all of what's necessary to become a mass market product, and it's really the best in the industry today. So why are electric vehicles so important? Well, first, they will continue to get better, and that's what we'll talk about in just a moment in the next section. But the other motivation is that automakers don't have much of a choice. Electrification is inevitable, whether that's coming from central governments that impose fleet-wide emissions targets or emissions regulations, or states like California and other CARB states, or China are now implementing zero-emission vehicle mandates requiring the offering and selling of plug-in vehicles. We also have local governments playing a much more active role, with some cities, particularly in Europe, looking at banning polluting vehicles, not just diesel, but even all combustion powertrains. And lastly, we have the impacts from consumer choice. Now in Sweden, even before COVID, they had actually seen a drop in air passenger travel. a drop that was contributed or associated with the flight shaming movement of consumers being more aware of the impacts of their choices on the environment and more people opting to take rail travel where possible. So this is a challenge. Automakers need to make electric vehicles, but they also need to make money, and they don't have much of a choice. So in this scenario, what can you do? Well, you need to innovate out of this conundrum. You can adopt new cutting-edge technologies to help make this mass market EV. And that's what we're going to talk about in the next section. So it's often cited that EVs are much simpler in their design and operation. They have fewer moving parts than a combustion engine. But I think it's an overstatement to say that an electric vehicle is a simple machine. Yes, you have fewer moving parts, but there are a lot of components that are included in the battery pack and the rest of the vehicle that really enable this vehicle to move. You know, of course, when we talk about vehicles, we normally think of the battery cell. This is the core unit. It's the most expensive part of an electric vehicle. But to actually turn that into an electric vehicle, you have to assemble those cells into modules. So group several cells together, include any thermal management pathways in that module, as well as sensors to monitor, temperature, voltage, current going through that pack as well. Then you assemble those modules into a bigger battery pack, which might consist of several modules. You have your centralized battery management system layer that manages operation and control of those. And you also have engineered your pack, so a physical enclosure that helps protect the battery. And then lastly, outside of just the battery pack, you have power electronics that help manage AC and DC power flows between the motors and the electric vehicle charger. You have the motors themselves. So there's a lot of extra complexity that goes into these vehicles. And we talk a lot about cells when we talk about electric vehicles because they're not only the most expensive component, but they've actually been at the core of better electric vehicles. So we manage a database of all electric vehicle sales and the specifications of all electric vehicles and have found that over time, cell prices that have fallen from roughly $700 to $120 per kilowatt hour for leaders in the space have translated to better products for consumers. OEMs are putting in more batteries to increase range. They're still able to pass on some savings to the consumers in the form of lower sales prices, while still cutting their losses and starting to get closer to profitability. So make no mistake, when we look at the last decade of electric vehicle innovation, cheaper batteries were at the heart of improved electric vehicles. But there is a challenge on the horizon, and that is opportunities for price reductions at the cell level are somewhat limited moving forward. Reducing costs through increasing scale of production to exploit economies of scale are mostly limited from here on out. Our analysis has suggested that beyond 10 gigawatt hours, you don't see significant cost reductions in the size of your annual production output of your facility. And you can rely on some chemistry-related improvements to help further drive down costs, which we've done here. We see a transition from about $120 to $100 per kilowatt, solely looking at chemistry innovations in the cell. But those improvements, as you can see, are somewhat limited. So making electric vehicles, once again, is not really an option. It's something that you're going to be forced to do to meet emissions regulations. How can you make them more mass market and more profitable? Well, what we want to stress today is looking at opportunities outside of the cell. Now, for those of you out there that are in the cell manufacturing business, we'd encourage you stay in there. There's a lot of money to be made in that industry. But we're encouraging the rest of the industry and ecosystem of suppliers that there are going to be opportunities outside of that area. And so what we want to do is highlight just a couple of the technologies that we look at that we think are important to the future of electric vehicles that are more focused on pack and vehicle level innovations. And the first one we've picked here is the battery management system. We think the BMS can help extract more performance from the battery. And to give you an example of that, we'll contrast the Tesla Model S, which is one of the more popular electric vehicles in the world, with a battery capacity of 100 kilowatt hours. Now that's what they say the vehicle has. In reality, the nominal capacity is a little bit higher, and the usable capacity is just a little bit lower. To protect the health of the battery, you reserve a little bit of capacity at each end of the state of charge window. Now, an incumbent OEM, Porsche, entered the space with a Taycan, with the vehicle designed to be pretty much directed straight at the Tesla Model S. Now, they included just a little bit less capacity in that vehicle, but have a significantly less usable capacity as well. They're reserving much more of their batteries that they can't use to protect the health of the battery. And EPA testing has shown that the range of the Porsche Taycan is quite limited compared to the Tesla Model S. Simply put, an improved battery management system would allow Porsche to use a wider state of charge window and allow them to gain access to the nearly 10 kilowatt hours of batteries they put in the vehicle that it doesn't use, which adds an extra 60 kilograms and roughly $1,500 to the cost of making that vehicle. When we look at a variety of battery management system technologies, we see that innovation interest in the space has increased quite dramatically with the advent of electric vehicles. And we see that on our Lux Tech Signal. Our Lux Tech Signal is looking at all kinds of data sources ranging from patent information, academic publications, VC funding data, and other proprietary data sets serve as a leading indicator of adoption of different emerging technologies. And compared to the average of the 4,000 or so technologies that we continuously monitor, battery management systems continue to score well. The key here is focusing on improving inputs for the battery management system, as well as adopting new charging algorithms. And we've talked with a couple of interesting companies that are developing solutions in this space, one of which is Titan Advanced Energy Solutions. And their claim is that they can improve the state of charge estimation of a battery management system by 2 orders of magnitude, which is an important claim because it allows you to have greater degree of confidence in your state of charge estimation and start to widen the state of charge window that you're using. So Porsche might not have had to reserve so much capacity at the top and bottom end of their state of charge window. Titan AES does this by, instead of simply measuring things like temperature and voltage, they're sending small acoustic pulses through the battery, measuring the responses, which changes due to the physical changes inside of the cell during the charge and discharge process. Another approach would be looking at charging algorithms. Now, some of us are probably actually using Qnovo, a startup company, using some of their technology in their cell phones as they've worked with various fast charging providers in the cell phone space. So Qnovo develops a technology based on quickly measuring the impedance and adaptively changing the charging speed to maximize charging speed while keeping the battery in a regime of low degradation while fast charging. And limiting the state of charge windows, one of the reasons they did that was to protect the battery cells during their rapid fast charging, as they had very rapid fast charging targets. Now, this is just one of the innovations that we looked at the pack level. There's also an important conversation to be had about vehicle level innovations and how automakers are actually putting together all of these different pieces of technology. So GM recently announced its 3rd generation BEV platform, BEV3, which is making an important improvement over its BEV2 platform, which underpinned the Bolt, which was more or less a one-off platform designed for just the Chevy Bolt, an important learning tool, but difficult to scale to other models. Whereas GM's BEV3 platform focuses on modularity across components so that it can underpin a large number of different vehicles and help lower costs. What I mean by this is they've chosen a modular battery. So by arranging modules in different arrangements, you can do anywhere from 50 to 200 kilowatt hour packs. So anywhere from a small hatchback to a large SUV or truck. They also have modular motors. They have a 250 kilowatt base unit motor that they can arrange in single, dual, or triple motor arrangements. Once again, to power anywhere from a small efficient hatchback to maybe a pickup truck that needs to be able to tow quite a bit of load. And then lastly, in this design, they've really focused on cost reduction through design at the platform level. By this, I mean they focused on reducing wiring by 88% compared to their BEV2 platform and reducing the number of electrical connectors by 55%. So they're lowering design costs by really focusing on design for manufacturing and lowering component costs, but also generating increased volume by sharing components across many different models to help reduce the cost of those components and consolidate their supply chain. Now, we've talked about component level innovation, we've talked about platform design, but what are the strategies that automakers are actually going to use to start addressing making the mass market electric vehicle? So we're going to revisit this quadrant through the lens of some of what we've just discussed. So first, automakers are going to increase their focus on efficiency as a way to improve profitability. Now here I'm not just talking about efficiency while driving. Certainly that's important, but the efficiency measure I'm thinking about is how many miles of range can you extract per kilowatt hour of battery pack size. Ultimately, customers don't care about kilowatt hours. They care much more about range. And if you can minimize kilowatt hours and maximize range, you'll be able to increase profitability by minimizing the usage of the most expensive component of the vehicle, the battery pack. And those savings can result in a combination of lower price, better profitability, and better performance, which is what we've seen in the past. Battery cost reductions have led to better range, lower prices, and a little bit more profitability on behalf of automakers. But they're also going to do this with these modular platforms that are likely going to be shared amongst automakers. You know, as I mentioned, these modular components allow one set of technologies to be manufactured that can underpin a large number of vehicles, helping to reduce design costs. But this can also be applied not just within the models that an automaker makes, but between different automakers. We've already started to see some automakers make their platforms available and start to partner with other automakers in making them. So we've talked about some of the technologies and strategies that are going to be important to realizing the mass market EV. But what specifically can you do to capitalize on this change and opportunity? So we're going to wrap up today by talking about specific stakeholders in the mobility value chain and what they can do about this. So the first opportunity we'll highlight is amongst suppliers and automakers. You know, we've talked a lot today specifically about powertrain efficiency, but the powertrain is not the only source of electrical load in a vehicle, of course. And to suppliers, I'd encourage you to think about overall efficiency. Climate controls are one opportunity. Normally with a combustion vehicle, you have a nice source of heat, usually right in front of you in the vehicle. But of course, with an electric vehicle, you need to make that heat, which is generally an energy-intensive process. So we're starting to see the first automakers, including Nissan and Tesla, use more efficient heat pumps instead of resistive heaters to help reduce range reduction in cold weather through operation of the HVAC system. For automakers, you can do well to start working down with your supply chain, past just your suppliers, to ensure there are no delays or issues with your vehicles. This is a phenomenon we've already seen. Several of LG Chem's customers have had to either pause production or reduce production output because of a shortage of batteries. However, we've also seen other automakers take very proactive moves. Companies like Volkswagen have looked at cobalt and lithium, whereas Great Wall Motors in China has also looked at securing lithium directly. So we're starting to see automakers directly sign some of these offtake agreements to ensure their cell manufacturers and electrode manufacturers have the materials they need to ensure they meet their targets. And this is important because missing environmental targets could mean steep financial penalties. So looking a little bit outside of just the automotive supply chain, there are opportunities elsewhere. You know, one would be actually in the oil and gas sector, which of course face a big threat from reduced demand with through mass electrification of the automotive industry. And in a post-COVID world, many are likely wishing they had a more diverse energy portfolio. And lithium could be that one interesting opportunity to help diversify that portfolio, because we expect there to be a shortage in lithium supplies by 2030 unless change begins now. The lithium space moves slowly. Bringing these projects online can take years and may even not be successful once they're commercialized. So tapping into the shared expertise between upstream oil and gas companies and lithium extraction could be a promising opportunity, because automakers and cell manufacturers aren't well suited to these types of capital-intensive, long payback period projects. So to oil and gas companies, this is an interesting opportunity to start diversifying your energy portfolio. And lastly, thinking about utilities. Of course, someone has to provide the power to charge all of these vehicles, and that would likely come from utilities. And almost all utilities that we've worked with around the world are already exploring how to mitigate this impact through programs like vehicle-to-grid and smart charging, pairing fast chargers with on-site storage. That's all really important, and you should keep doing that. But there's also a longer-term challenge with what if all the electric vehicles in the world plug in at the same time? Because that requires a significant amount of power if they're all using fast charging. Here we've analyzed, based on some of our electric vehicle forecasts, just what is the maximum amount of electricity that electric vehicles could consume. And by 2030, 200 or 350 kilowatt charging could exceed the grid capacity, or I'm sorry, the global generation capacity. Now, obviously it's worth noting, this type of scenario where all vehicles are plugging at the same time is unlikely to happen. But you don't need to exceed generation capacity before the grid is really struggling with maintaining operation and reliability. You know, even just 10% of these vehicles charging, could that disrupt the grid? And here we're only looking through 2030, where sales will continue to grow in the future. So thinking about some of these high traffic days, such as summer holidays, this could be a major challenge. And it's worth thinking about long-term solutions, things like battery swapping. It failed with a small number of EVs on the road, but we're seeing resurging interest, specifically in China, to support things like taxi fleets or luxury electric vehicles, where it could once again decouple power consumption from power generation, an important tool in the EV sector for utilities. And lastly, for everyone, make sure that you're applying these principles while working on the right timeline. EV adoption will be slow and steady, and it won't happen overnight. Even when we hit one of these metrics like cheaper batteries, it's not going to result in a dramatic uptick in adoption. So make sure, once again, to work on the right timelines. So to summarize today's discussion, we really aren't in an age of mass market electric vehicles, at least yet. With improvements in electric vehicle efficiency and a focus on shared modular platforms, could see a reduction in costs and improvements in profitability that could push the electric vehicle into an era of a mass market product. And finally, infrastructure and the supply chain remain long-term challenges. So for those of you in the oil and gas and possibly utility space, it's an opportunity for you. And so with that, we'll now open up for questions. So as a reminder, there is a question box. Please enter your questions there, and we'll be answering them as they come in. So we've had a few come in throughout the webinar today. We see one question. We didn't really talk a lot about COVID. The question is, will automakers scale back electrification efforts due to COVID? This is a very good question. So, really right now, it looks very unlikely that's the outcome. Governments have mostly been moving in the opposite direction. We haven't seen a relaxing of efficiency or emissions regulations. What we have seen is keeping those in place, but as part of industry economic relief packages, seeing an extension of subsidies, increasing incentives on electric vehicles, and this appears to be the global response. Essentially keep these emissions and efficiency laws in place, provide relief through subsidies to encourage adoption. And automakers really see the writing on the wall that there is going to be no kind of backtrack from this global push to reduce emissions. So in that sense, really what they have been scaling back in a post-COVID world are some of their longer-term bets. So we saw Daimler actually announced they weren't going to continue with their passenger fuel cell vehicle program and instead formed a joint venture with Volvo to focus on heavy-duty vehicles. And some of the automakers that had bets in shared mobility or different mobility services are cutting those back, like GM has done with Maven. So it seems like electrification is really the aspect of the future mobility that automakers are very much focused on. Looking through some other questions, I know I encouraged everyone to think outside the cell, but we see quite a few battery questions. So one here is $100 per kilowatt hour the magic number for price parity? So I would say not exactly. This number is thrown out pretty frequently, and I think it's thrown out very frequently when talking about price parity because it is kind of the right ballpark. There are a lot of variables that really are involved if you want to calculate a precise price parity calculation. You know, one big consideration is how much range do consumers need versus how much do they want. So, you know, the Tesla Model 3 provides 300 miles of range, but very few trips each year will need that kind of range. So would consumers be happy with 150 miles of range from half the size of the battery pack? You know, in that case, maybe 100 kilowatt hours isn't exactly the magic number. So it does depend on vehicle design. But I think at the end of the day, it is the right ballpark. And I think the industry has picked that because it's a very nice round number. I think we have time for one more question here. There's one question, do startups have a shot at succeeding in the future? So it's certainly a harder environment today than when Tesla was successful for a startup to succeed. You know, when Tesla was, you know, if we go back 5 years when they had just released the Model S and were really gearing up for the Model X and Model 3 rollouts, you know, very few automakers had an active electrification program. You know, they made a lot of money by selling and pooling credits with other automakers to meet some of their emissions and efficiency targets. And, you know, even if you look at Toyota Daimler, I mean, they were licensing powertrains to those organizations and partnering with them to develop electric vehicles for them. Whereas today, it's a very different environment. You know, every automaker, most automakers, I should say, have a very active electrification program and themselves are investing billions of dollars into, you know, organizing their supply chain, designing their platform, et cetera, to underpin. So, you know, in that sense, the competition is much greater and the field is very crowded. That being said, I don't think it's fair to say they don't have a shot at succeeding. You know, you can look at a company like Rivian as finding an interesting a way to succeed, which is, you know, leveraging the fact that you as a startup have designed a platform. So they're working with Ford and partnering and likely going to build a vehicle in the future where it's a Ford-branded vehicle powered by Rivian. And also tapped into an investment from Amazon where, you know, Amazon is on its way to becoming a major fleet owner. And, you know, of course, have the capital to start, you know, investing in building their own electric and autonomous vehicles. So it's not impossible. It's crowded and, you know, it's going to be very difficult to break into that space, but a handful of companies, I think, will succeed. And so with that, we're concluding today's webinar. If you have any other questions, feel free to email questions@luxresearchinc.com. And once again, thank you all for joining. Have a great day.